So hello everyone, and thank you all for coming to my talk. My name is Danny, and I do security at Snyk. We're a dev tooling company based here in Tel Aviv and in London, and we're building security tools that help developers use open source code securely. And I'm also a CTF player playing Capture the Flag competitions with my team, PAS10, and we had the honor to win the CCC and the Google Capture the Flag competitions for the last 3 years. Anyone? Sorry? The selfie challenge. What does it mean? I should take a selfie with the audience? Is it now or in the end? Okay, so let's do it now. Woo! All right, so and this is Brian. This is one of our lovely dogs at the office. And earlier this year, he started a new research project hunting for vulnerabilities in open source code. And in particular, he looked at the Jenkins source code and its different plugins. And he stumbled upon this function. Can you see this clearly? Yeah, OK. So this is a Java implementation of a zip file extraction. Pretty simple one. Basically, we construct a zip file object out of a file, get the entries of the zip file, and then enumerate over all the entries. For each entry, we construct a path, basically concatenating the target directory where we want to extract the files with the entry name. And finally, write this onto a disk. So by show of hands, how many of you can spot the issue here, a security issue with this code? Not too late. You can go to the other talk still. But kidding. This is actually a vulnerability. The problematic line is this one. And let's see why. Basically, if we take a sample backup file, backup zip file that has a single file, backup txt, and call this function, providing the destination folder /tmp/extracted with that backup file, what will happen is what we would expect, right? The txt file would get extracted into the temp extracted folder. But what if we take a different file? We construct a different file and add another entry to it. In this case, we can see that the original backup file exists. So the backup txt file will get extracted as expected. But when we will get to the entry, the second entry, we basically will concatenate the destination folder with the path. And that will result in a different path. So we can see here that it's a completely different path that actually ends up outside of the destination folder. So this issue with zip, with archive extraction isn't new. It's been known for more than 20 years. But when we looked at the different open source packages and specifically open source libraries dealing with archives, we found all of these packages vulnerable to this simple and pretty old vulnerability. And so we can see that Java is in particular affected. There's 5 different libraries that were affected. But for example, Python is not here. And we will later see why. And this is just the open source libraries that deal with archive extraction. There was much more affected projects that we found that were just general applications. So we see 5 different Apache products affected, starting from Storm to Ant, Pivotal Spring, Jenkins plugins, Amazon plugins as well, so SonarQube, and this is just like a partial list. Lucy is like this ColdFusion open source ColdFusion. So this thing resulted in a long list of CVEs, and this is, again, a partial one. And an important thing is that this vulnerability does not affect only zip files. It actually affects any kind of archive format. So quick distinction between archiver and compressor. Archiver is basically archiver is a file format that groups other files together. Compressor, on the other hand, is something that compresses files. So some of the file formats, like zip, is actually both an archiver and a compressor. But tar would be just an archiver. All tar can do is just group files together without any compression. On the other hand, gz or gzip would be just a compression. That's why we oftentimes see them together, tar.gz. Basically, one would group the files together. The other would just compress the stream. So any kind of archiver would be affected by this vulnerability. So how come there is so many Java projects in particular, but many others that are affected by this old, more than 20 years old vulnerability? So when we look at Python, for example, if a developer wants to extract a zip archive within Python, it's pretty simple. We have the zip file library, and it's a library provided by the runtime, by the Python runtime. And so all we need to do is just to call this single method called extract all, provide the destination folder, and our files will be extracted. So basically, very simple single line of code that the developer, almost like single line of code that the developer needs to call. Same goes for .NET. There is a zip file class that has this extract to directory method, and it would extract the zip file into the directory, all the files in it. But when it comes to Java, so in Java, there is the standard library provides us with different classes like zip file and zip entry, but no high-level functionality of extract all. And this is most often what we as developers want. We just want to open the file. And same goes to the second most common way to deal with compression and archives is the Apache Commons Compress library. It too lacks the high-level API. So that's how we end up basically writing this code again and again just to extract a zip archive. Oftentimes opening the stream and then enumerating through the entries, doing the same things again. And of course, omitting the check for directory traversal file names, like we've seen in the Jenkins code. So, of course, when there is repetition and there is some challenges about, when there is no single line of code that we can quickly write, we just go to Google and pour our problems there, and oftentimes find ourselves on the Stackoverflow site. And I'm sure many of you have found a number of helpful answers to really obscure questions on this site, and this is a really great resource. But it also leads to what is known copy-paste oriented programming, or like this imaginary O'Reilly book describes. So again, in many cases, copy-pasting just works. But copy-pasting code without understanding the issue, without understanding the code itself, is obviously a problem. So when we looked at the different questions and the answers when it comes on Stack Overflow that were asking about zip file extractions or any kind of extraction, tar files, what happened is that almost all except one answer had vulnerable implementations. And again, remember, like for Java, unlike Python, for Java it's just like 30 to 50 lines of code. So most often people just take the code, paste it into their own code, just adjust the variables, some exception handling, and voila. So, when it comes to So as I mentioned, almost all of the answers had vulnerable implementations. And here we can also see some frustrations. I'm not sure you can see it here, but basically, you can see also on Stack Overflow the frustration that comes from the developers, basically ranting about all the crazy things that they need to do just to extract an archive. And so same goes for this funny comment here. Yeah, basically, what the developer here is saying is that eventually every Java project has some sort of ziputils.java class that has an unzip implementation that almost often, many times just comes from Stack Overflow or other open source projects, and again, is just many times appears to be vulnerable. So yeah, and that one, a final one, yeah. So when we found all these issues, basically we had about 10 vulnerable libraries across different ecosystems and languages. We had several hundreds of open source projects that had the same issue, not because they used the vulnerable libraries. That's a different kind of issue. That shameful plug here, shameless plug here, it's Sneak helps with that. But in this case, they actually implemented their own Java extraction, zip file extraction implementation. So basically, we found that several hundreds of open source Java projects that just did their own unzip logic, again, copy pasting from other projects in many cases. And so the result was that there are kind of 3 different problems we had. First is lack of high-level API in some languages. Second is the vulnerable libraries that deal with extraction, archive extraction. And third, different projects that are just vulnerable to this issue. So we had to find a way to disclose all that without kind of all blowing up. Because basically, these are all open source projects, and the fixes are visible. And so we kind of needed to coordinate between everybody for the fix to roll out. And so we could eventually go public with that after all the projects were fixed. So what we did, we followed the Google Project Zero model. We chose 60 days to be the disclosure period. Coordinated the fix with the different vendors. And so we started with the ecosystems, basically reaching out to all the big players, Oracle and Apache, and started to work with them on all the particular libraries that were affected. And next step, we reached out to the actual libraries that were vulnerable. In many cases, these were just unmaintained or just very popular but unmaintained libraries. So we opened fix pull requests to about half of them. And there was one Go library that when we reached out to its maintainer, he said, like, this is something small I wrote for myself 3 years ago. I don't think it should be used in production. And that's when we told him that this is the most popular Go extraction libraries out there with like more than 1,000 GitHub stars. And so he first time realized that his code became just like one of the most popular Go libraries for archive handling. So that one was fixed as well. And then we reached out to major applications like Spring and Pivotal, LinkedIn. Like there was a long list of big vendors that we reached out to. And finally, we just did a bulk kind of disclosure, automated one, to all the smaller open source projects out there that could, again, we wouldn't be able to manage manually, but we still sent an automated email to all of them based on the emails we had from the GitHub repository. And finally, we went public with all the data and did the CV assignment. We actually are a CNA, a CV numbering authority, so that one was easy. We just assigned the CVs that same day. We also created this collaborative GitHub repo to track all the affected libraries and projects, and so you can check this link out and open pull requests for other affected libraries and issues. Basically, you'll find there all the affected libraries across different ecosystems, all the affected projects, and also vulnerable implementations that were not exploitable, but still were defensively fixed. Basically, our goal here was to kind of mitigate this issue completely, and even though the project maintainer would tell us in some cases that this is not exploitable issue, just because, for example, the zip is not coming from a user, thus it cannot be malicious, we still suggested to fix the implementation just because this code might become vulnerable later on or just continue to be copy-pasted to other projects. So there is a separate list of projects like that. So we just wanted to acknowledge that, but without assigning CVEs and making it a real vulnerability, because it's not. So it would be all on that page. And so just to summarize several takeaways, obviously don't trust user input. That's an easy one. Don't be the full Stackoverflow developer. Don't just blindly copy-paste code from Stackoverflow. Use that resource, learn from it, try to understand the problem better. But yeah, try to avoid just taking the code you don't understand. And again, here also tend to use external libraries, because as soon as you copy-paste code into your someone else's code into your code, basically it's just like statically linking into your a library into your code. So when the library gets fixed, you basically don't know about it. So for example, all the libraries that we found the vulnerabilities in, when we fixed them, all their users got a notification about the security issue and had the chance to upgrade. But when somebody copy-pasted a vulnerable implementation of this code, there is nothing much to do. I mean, it just became part of the code base of that developer. So yeah, and design simplified APIs with strong security defenses implemented by default. So Java is just a good example. Like, we couldn't find a single affected Python project, and almost like 90% of Java implementations of zip extractions are vulnerable. So like, that's pretty crazy. I mean, Java is a very, very mature ecosystem. It's not something new. Like, oftentimes, you hear NPM and Node.js being criticized for different security issues. But Java, yeah, they've been here for a while, and still chose, both Oracle and Apache chose not to provide this high-level API, probably without knowing the impact, but still, this is something that is being fixed as we speak. And finally, there is a lot of interesting data you can dig into in your research. So Google BigQuery, there is all the data from Stack Overflow actually is in Google BigQuery. I encourage you to check it out. You can just do your own analysis of what developers prefer to do or search for vulnerabilities in different answers. There is a bunch of really cool research that's been done, starting from the number of times developers write the word fuck in their comments to really like to things that are actual research. So do check it out. And finally, one research that was looking into different vulnerabilities, basically into different challenges and issues around secure code development with Spring. And so they looked at different aspects of the Stack Overflow usage, and also found a bunch of issues around, for example, questions around cryptography. So oftentimes they would see that people just disable the different security features, and since they disable the security feature, the project begins to work and it solves the problem. So the answers get upvoted on Stack Overflow, and so that The most popular answer, the one that works, you know, like it fixed everything. I disabled the SSL certificates. So, these answers oftentimes become the most popular one. And so they identified a bunch of issues around that. And that's all. Open source is awesome, and please enjoy it responsibly. And we got some time for questions, I guess.
That means you have to do the challenge, the selfie challenge.
I already did it.
Oh, you did it, so you're...
Maybe you'll be more excited now. Woo! Yeah, thank you.